Okay, we have here an interesting trig integral from the MIT Integration Bee 2020, number 7. We've got the integral sine to the fourth x, cos to the fourth x, cosine x plus sine x times cosine x minus sine x dx. Okay, there's probably a lot of different ways to do it, but the thing I want to notice, when we've got something, it's nice that we've got the same power here, because we could kind of group it together and write it like, well, not quite like that. We could write it like sine x times cos x all to the fourth. The reason I want to do that is if we had this like 2 sine x cos x, this is just our double angle formula. This is the same thing as sine 2x. And then bringing this over here into it, if we just multiply this out, what we get is cosine squared x minus sine squared x. This is the double angle formula for cosine, so this is actually going to give us cosine 2x. The nice thing about that is we can get everything in terms of the double angle 2x. So to make this work, over here, we don't quite have this because we don't have the 2. So what I want to do there is let's just kind of force the 2. We'll create that. And so I don't change it. Because we're inside the parentheses, I just multiplied by 2 to the fourth so that we get the same thing. If I just divide off 2 to the fourth, this is the same thing as multiplying by 1. So using this, what I'll do is I'll take this and we'll bring it up front. Actually, let's just write it as 1 over 16 for 2 to the fourth. And then 2 sine x cos x, I'll write it this way as sine 2x all to the fourth. And then everything over here, that's just going to be our cosine 2x. So we'll write that in right here. But this is looking pretty good because then we can do a u substitution on it. If we set u equal to sine 2x and take a derivative, first we're going to get cosine 2x. But we need chain rule, a 2 is going to pop out, dx. So in order to set up this du, let me just multiply in a 2 here. And again, so I'm not changing it, I'll multiply 1/2 up front. So then I'll go ahead and substitute. This here is going to become 1 over 32. Then this is just going to reduce down to u to the fourth. All this is du, and now we've got a simple power rule integral. So it's going to happen 1 over 32. Integrate this, we get u to the 5 over 5. Let's go ahead and back substitute on it. I'm not going to simplify it because I think it's going to work out nice if we don't. So this is going to be sine 2x to the fifth, but a lot of times people like to get it back to the way it was originally. You really don't have to, but it's kind of tradition. So in the problem, we've got it as single x's. So let's get it back to single x's. I can write our u as 2 sine x cos x. So then plugging it back in this way, what I'm going to do is everything's to the fifth. So I can write it as 2 to the fifth, sine to the fifth, cos to the fifth. And 32 is going to be just 2 to the 5 times 5. But I can cancel the 32's here. And so for my final solution, we have just sine to the fifth x, cos to the fifth x over 5, add a plus c, and that's it. It's kind of nice how they got a 5 everywhere. It's too bad they didn't get 20/20 there. It would have been more appropriate for the problem. Pretty nice solution. So that's it for today. Thanks everyone for watching. Have a good day. No.